Question 9. Okay, when a liquid is boiling, a thermal energy, which is heat, must be supplied in order to maintain a constant temperature. Okay, so the question is saying that when you boil a liquid, its temperature never change. So since the temperature never change, then how come we still must supply heat? Okay. Since there's a heat supply to the liquid, so why doesn't the temperature rise? What happened to all the heat that we supply to it? So during the heating, during the boiling, the heat must be required to do something else, something other than raising the temperature. So what is the something else that the heat is doing? Okay, there are two processes that the heat is doing. Okay, the two things that the heating is doing is, first, the heat will be required to break the bonds between molecules. Because when it's in a liquid form, the molecules are actually bonded. The molecules are not free from each other; they are bonded. So when they reach a boiling point, what the heat does is the heat will be using to break the bonds between the molecules. Then the second thing that the heat does is it need to do work against the atmosphere during expansion. Because when liquid change to gas, there's a big increase in volume. And this big increase in volume doesn't take place in vacuum, it takes place in the atmosphere. So the liquid must do some work to expand against the external atmospheric pressure. To do work against the atmospheric pressure, you need energy. So that's what the heat is. That's what it is used to, is to provide the liquid with energy to do work against the expansion. So there are two things happening during boiling. One is to break the bonds between molecules and to do the work against the atmosphere during the expansion. Okay, then part B. A student carries out an experiment to determine the specific latent heat of vaporization of a liquid. Okay, so this is the apparatus. So you can see that this liquid is being heated up by this heater. The heater is powered by electrical circuit. So the power here is the electrical power is used to heat up the liquid, and the liquid should be at the boiling stage. You convert the liquid to gas. Then these are the data. Okay, they take two separate data. Basically is they vary the power, and then they measure the mass of the liquid that has evaporated in 5 minutes. This question is very similar to the previous tutorial question 7. Is heating up the water, but they also give us two sets of data. Okay, just that in this case, it's boiling the water. So instead of using Q equals to MC delta theta, in this case we use Q equals to ML. And again, we apply the same trick. This is power, and this is we divide by time. So it's Q over T equals to ML over T. Okay, Q over T being the power. And again, the same trick. We do it 2 times. Why? Because we want to take into consideration the heat loss to the surrounding. And so we're going to have these two data put into a 2 simultaneous equation, and that's how we get rid of the heat loss to the surrounding through simultaneous equation. So for part 1, explain why we have 2 sets of data. The reason is because you want to do a simultaneous equation so that we can cancel out the heat loss to the surrounding, to the atmosphere. Okay. Here in the answer, they say the answer cannot be to prevent or to stop the heat loss, because by doing 2 times, we don't stop the heat loss. The heat loss is still happening. It's just that we acknowledge that there's a heat loss, but we are able to so-called cancel out mathematically by doing the simultaneous equation. Okay, part 2. So the equation will be P equals to ml over T plus the heat loss to surrounding. Okay, we will sub in the two sets of data into the equation to get two simultaneous equations where the two unknowns are L and the H. And that's how the H can be eliminated mathematically through solving simultaneously. Okay. Now, one thing note about how we substitute, because they want our answer to be in joules per gram, and in this table, it has minutes. Okay, power watts is in second, joules per second. So we need to convert the minutes to second. But at the same time, the gram we don't need to convert because they want in gram. So that's why over here, the mass we leave it at 6.5 gram as it is, but the time we convert the minutes to seconds. So 5.0 times 60. Likewise, the second data, we also do the same. 13.6, we leave it as gram and divide by time convert to seconds. Okay, so we solve simultaneously, we will get the answer L equals to 845 joules per gram.